Welcome to How to Inspect for Moisture Intrusion course. This goal of this course is to teach students how to identify and report moisture intrusion in homes and commercial buildings. So once you get to know this, this is a pretty in-depth course just to let you know. Now I'm going to read this right here because this is what the introduction is all about, and you can read along with me. Follow the bouncing ball. This course teaches many of the best building practices and standards that make a home moisture resistant. Now, building practices and construction techniques are essential for an inspector to understand. Building components that are defective, incorrectly installed, or simply missing can produce moisture-related problems. Moisture intrusion of a building can cause major structural damage and can threaten the safety of its occupants. Most E&O insurance claims in the industry involves moisture intrusion. Once an inspector knows what properly installed building components look like, they recognize the inspection or the installation defects, and that becomes a lot easier. Education and training on the best and most recent building practices for controlling moisture are essential for every property inspector. So I hope you all get a great inspection after this course when it comes to moisture. So something I like to quote is other people. And I remember what Benjamin Franklin said: an ounce of prevention is worth a pound of cure. That's especially true when it comes to moisture intrusion. Catching a small issue today can save a homeowner thousands of dollars tomorrow. And that's one of the biggest values we bring as home inspectors. Throughout this course, we're going to look at how homes are supposed to handle moisture, the common mistakes we see during inspections, and how to identify and report those issues properly. My goal isn't just to help you find a stain on the ceiling, it's to help you understand what's going on and how to help you identify where that problem started or may have started. I've always said one of the biggest enemies of homes isn't termites or age, it's actually moisture intrusion. And it's all on how it's built. And it's going to find the weakest point. Moisture will always find a way. Years ago, the homes were built focused to keep the rain out. Today, they're much tighter. There are more expectations that are higher now. And it's more energy efficient. They're more comfortable, they're healthy, they're free from mold. That means moisture control has to become much more than just fixing a roof leak. It's all about controlling humidity, protecting the indoor air quality, and making sure the home can dry out when it does get wet. As inspectors, it's important that we understand how a home is designed to manage the water. You have to understand, you don't have to be an engineer, but you have to understand how it all fits together. We're not code officials, we are home inspectors. And we want to check out the flashing, the grading. We want to check out the gutters and how far away are they from that property. Or even in improperly installed windows and doors can also allow water to get where it doesn't belong inside your house. And one thing I can tell my customers, if you don't control the water, that water will control you. And effective moisture management means being very precise when it comes to understanding water control. Now, moisture movement can be kind of confusing because there's a lot of building terms when it comes to the source of where moisture actually is. And as inspectors, you don't need to memorize all of them, but you should understand the basics because the basics is what's going to drive you to that next level. So communicating well with your customers and with the builders and the contractors and people that are around you, you have to understand how it works. So there's two most important items that we're going to be talking about: the vapor retardant or vapor retarder that slows down the moisture moving through whatever material it is. And then you got the vapor barrier, and I kind of think of it like a pool where it's going to stop the water from penetrating, or it's going to, at least most of the water from penetrating, or the moisture. The easiest way to remember it is Vapor retarder slows moisture, and the vapor barrier stops most of it. It doesn't stop all of it, but it does stop most of it. And that's what we want to continue to focus on. And that's what this slide is really all about. We want our buildings to be water resistant and not so watertight where water isn't going to get out if it does get in, if that makes sense. So many of the home or many of the moisture control features we talk about can be seen through the home inspection, but not all of them because we have things that are in our way. It's only stuff that we can visually see. And just because something isn't visible or isn't built using today's best practice doesn't automatically mean it's defective. It or it may or may not cause a moisture problem. Remember, a home inspection is a visual, non-invasive practice. We don't open walls, we don't move furniture, we don't remove finishes. So many important moisture control components are hidden from that view. Our job is to report what we see at the time of the inspection, recognize those signs and the potential of those moisture issues, and recommend further evaluation when needed. That is the most important thing that you should do in every home inspection is further evaluation from whatever source. So you got air, moisture moves throughout this planet. It's always constantly moving. So the air current is one of the biggest ones. And I think of it like your breeze in the air is actually carrying moisture. And a lot of times, like when your kid gets sick, what do? You put a vaporizer in their room so that they can breathe better. So when warm air moves through gaps around like windows and doors and electric outlets, attic hatches, whatever, when that warm, moist air hits a cold surface, it turns into water vapor, right? And it's kind of like, if I took this and it's water. If it's cold, it's going to actually have some condensation. So think about that cold glass of iced tea or the hot on that hot day, forms of water will touch the glass and all of a sudden you got water out there. So that's one way that water or moisture actually moves. Diffusion through materials is another. Now think of that like a sponge and it slowly like soaks up that water. Even if there are no holes or air leaks, water vapor can slowly pass through materials like you think about like drywall or wood or insulation. I like to think of it as like a big sponge. It moves from area with more moisture to areas with less moisture. That's just how it works. So if you're ever smell someone's cigarette smoke or perfume through a wall, you've seen diffusion at work because moisture can move the same way. It just moves much slower. Now, the other way that it moves is through heat transfer. And heat transfer, it carries moisture through colder areas. Warm air naturally moves towards cooler areas. As it does, it carries moisture. When that warm, moist air reaches a surface that's cold enough, the moisture changes into liquid. And in the wintertime, you're going to see this, especially people from up north. The warm air inside your house moves towards the cold attic or outside walls. If those surfaces are cold enough, you'll get condensation, just like fogging up a bathroom mirror from a hot shower or bath or whatever you're doing. Easy way to remember it, tell people there are three ways moisture moves. Air carries it, materials carry it, and heat drives it towards cold surfaces, where it often turns into water. One thing to remember, water always follows the path of least resistance. As inspectors, our job is to figure out where it's coming from, where is it going, and whether the home is handling it the way it is designed to handle it. So, hope everybody got that. Moisture is one of those things that just it can really stump a person. A few years ago, I got a call from a customer, and she wanted me to come out and check out because she's having some stains on the ceiling. We checked everything, and it actually turned out to be the air conditioning system that was actually condensating. So, again, moisture can be something completely different. And they actually paid for a brand new roof because they thought the roof was leaking. So, thermodynamics is simply the movement of heat. Heat always moves from warmer areas to colder areas. As warm air moves, it carries moisture with it. When that warm, moist air touches a cold surface, the moisture turns into water, called condensation. Remember, warm air holds moisture. Cold surfaces make it turn into water. That's why not every moisture problem is caused by a leak. You'll see that time and time and time again. So, so we're talking about vapor pressure and relative humidity on this slide here. And vapor pressure is simply the force that causes moisture to move from one humid area to the less humid area. So it's really easy to remember. Moisture moves from wet to dry, and heat moves from warm to cold. So just remember wet, dry, warm, cold. It's kind of like when you're driving down the street and you see the fog. The warm air is moving to the cold. So anyways, it's kind of a good way to remember it. So there is some simple math here. And again, you don't have to memorize this, but it's really good to know. In controlling air movement, we also control temperature and moisture. Insulation helps keep warm, cold temperatures separate, while vapor retarders slow that movement of moisture through walls and ceiling. Together, insulation and vapor retardants help reduce condensation and protects the home from moisture damage. So just remember that warm air carries more water vapor than the cold air. And you can think about that when I'm from Minnesota, where it got really cold and you get a lot of static electrical charge in the wintertime because there's not as much water vapor in the air when you're getting into your vehicle and then you touch something metal and well, that's because there's not a whole lot of condensation out there. So, so understanding the vapor movement is understanding how water vapor actually moves can help all of us home inspectors recognize whether vapor retarders or are working the properly and identifying conditions that could actually lead to those moisture problems. Water vapor can be a source of damage when it is trapped between any type of building assembly. So we want to make sure that it is properly flashed and all that stuff. And we're going to get into that a little bit later in this webinar here because it's really kind of cool if you can start your inspection on the outside, working your way in, understanding where the water's coming. If you're not controlling it, again, water's going to find its way. That's just all there is to it. So even if a home really has no air leaks, sometimes you can actually have moisture problems too. And so this vapor diffusion and moisture control is something we need to understand as home inspectors. Again, I don't expect everybody to memorize all this stuff. Just kind of keep it on that back burner so that when you need it, you kind of understand it. So if a home has no air leaks, water vapor can still slowly move through those materials like the dry wood and the wood and the concrete. And this process is called diffusion. And that's why the term vapor barrier can be misleading. Those materials don't completely stop moisture. They just slow it down. That's which is a better term is vapor retarder. So instead of vapor barrier, if that makes sense. Vapor retarders are commonly installed in those crawl spaces between the walls, ceilings, and basements to help reduce moisture from moving into a house. Where a vapor retarder is installed depends on the climate. So in cold climates, it's usually placed on the inside of the wall. In warm climates, like here in Florida where I live, it's placed on the outside of the wall. The important thing to remember is vapor diffusion isn't the biggest source of moisture problems. Most moisture enters a home through air leaks, plumbing leaks, roof leaks, and capillary action. I can't speak today. Sorry, people. Bottom line, vapor retardants help slow down that moisture, but air sealing it even more important for controlling that moisture in the home. So here we have like um, the diffusion retarder in 2015, the International Residential Code defines vapor retarders based on the measure of aha, I just drew a blank here. Um, measured on diffusion of vapor barrier. It's a measure of units called perms, and permittivity is the higher perm rating, the more easy water vapor can pass through it. So the less, the better kind of thing. In 2015, the IRC described three classes, and here's your three classes of, less than zero point 0.1 perm, greater than zero point 0.1 perm, and you guys can read that. So in this picture here, so where you live also is a big factor when it comes to humidity. So like here in Florida, we have a lot of humidity, which means that there could be a lot of mold in this area because of moisture. And mold thrives on having moisture and food stores. And that's exactly what it is perfect for here in Florida. That's why the vegetation grows so good, is because of that, the vapor, or the water vapor that's in the air. And I personally think that's why people live longer too, is because of the huge amount of moisture that's in the air here. But it can also cause problems if it's not correctly designed for this type of climate. So I'm not going to build a house like I do up in Minnesota here in Florida, because we're going to have moisture issues. So we got to have the right type of perm in each sections that you need it. So like your crawl spaces and attics. And like here in Florida, it's on the outside of the house instead of the interior wall where we're putting the poly on. So if that makes any sense for a lot of people that are up north, you understand building. We used to we'd put the built right on the house, and then we'd put the poly on the other side. Now we put the built right and the poly on there, and then we have ways of the moisture to get out of the wall if it ever does get in there. And that's how they build houses in Minnesota. Here it's just a little bit different. Same ideas, just to control that moisture as much as you possibly can. And this map actually shows what you should be looking for. So anyways, let's move on. Class 3. So vapor, um, sorry, building practices have really changed over the years. Today, many homes no longer need that heavy duty class 1 vapor barrier. In many climates, a class 3 vapor barrier or retardant should, such as like latex paint, works really well, because modern wall systems are designed to let moisture dry out. The Department of Energy also recommends allowing walls to dry to the inside, the outside, or both, especially in like mixed and warm climates like here in Florida. So, bottom line is the goal isn't to trap moisture, it's to manage it and let the wall dry when it gets wet. So that stops a lot of problems right there. So we're learning as more houses are getting built, and the way standards are changing and stuff, because we're understanding more and we have more technology, so we can actually measure this a lot better. So vapor diffusion retarders um, and come in different forms. So including like the plastic sheets, the rigid foams, you'll see that quite a bit. You got special coatings, you got certain types of insulation. Their job isn't to slow movement of moisture vapor, but not to completely stop it either. It's just there. So where a vapor retarder is installed depends on the climate. In cold climates, it's usually placed on the inside of the wall. In hot climates like Florida, it's on the outside. It's often placed there because of how we figured out how the moisture actually moves. For a vapor retarder to work well, it needs to be installed continuously with all the seams taped, holes and tears sealed. Even small openings can let moisture pass through it. In many existing homes, multiple coats of paint already act as the vapor retarder. So adding plastic sheathing is sometimes unnecessary. So remember, installation does insulate well. It doesn't insulate well. It loses its effectiveness and can lead to condensation. It can wood rot, mold, insect damage, things like that. So you got to remember that when you see wet insulation, make sure that you report it as such. So the vapor retarder slows moisture down, but it's only one part of moisture control. Proper air sealing, installation, flashing, drainage, and ventilation are all just as important to control that moisture. So when you're inspecting moisture, a lot of times what I do is I like to use my little FLIR camp. And I like to kind of demonstrate that this doesn't pick up everything, but it will pick up a lot of things throughout the house. And sometimes this will just give you a good idea, but you can also pick up moisture meters like this one or this one. And what I did is I actually put something on the bottom of this so I can actually screw that on to my selfie stick and I can actually reach up to the ceiling and stuff. So those are some ways that you can actually test for moisture, just not just by visual, but by actual some measures here. So I really like to tell inspectors, especially when I'm training them, make sure that you're checking around the exterior, especially, and then around some of the bathroom areas too. So some of the standards um, are kind of beyond what InterNACHI says the bare minimum standards are. So it's kind of nice to give that customer just that little bit more. So, uh, yeah, I think that's all this is here is discussing, inspecting for moisture intrusion. Make sure that you're checking a lot of this stuff out by moving like the insulation. If especially if you have basements and stuff, just looking at the insulation, making sure that there isn't no effervescence or any of the water staining and stuff. Just taking a few minutes on each wall. Like I like to do 4 feet at a time and just kind of work away around the building just so I don't miss nothing. So that's something that you can do. Now, moisture resistant roof systems. This is one of those things where it can really be tricky to inspect. So, roof covering provides a first line of defense against all the elements. We all know that. They also tend to be the most exposed component of the building. So, we have to understand that roof covering should be selected, detailed, and installed to provide durable resistance against water penetration. Now, you're going to hear me say it's resistant. It's not waterproof. It's not watertight, but it is water resistant because more than 75% of homes in the US use a composition of roof shingles. We will focus on this type of roof system in this course. Home inspectors should know the importance of minimum roof slopes for the various roof coverings. Underlayment installations are not readily visible, but sometimes you can see them like when you're in the attic and where the sheathing meets each other. You can kind of see what the underlayment is. You want to check the rake and you gently lifting up the edges of the shingle, you can actually look underneath there, but just be careful if you are going to do that, not to tear it or damage it because you don't want that on your So just make sure that when you're checking the roof system that you are, like I said, I do 4 feet at a time. I kind of do the same thing with a roof. I kind of work the exterior first, and then I just kind of work my way up and check the roof on all the slopes. And then when I'm in the attic, I make sure that the slopes are right. And if I see like a 112 pitch and I'm seeing shingles on there, I'm going to mention it to the customer that that isn't really recommended. So, um, some manufacturers do recommend it, but I don't. So, anyways, minimum roof slopes and underlayment. A roof slope is important because it helps water drain away. Now, steep slope roofs are designed to shed water, not hold it back. So they rely on the roofing materials and the underlayment working together to keep the home dry. Roofs with a slope of 412 or greater typically require one layer of underlayment. Roofs between 212 and 412 drain more slowly and usually require two layers of underlayment or some other extra protection. In colder climates where ice dams are common, an ice and water shield is installed along the eaves and to prevent that water from backing up and underneath those shingles. And I'm so glad I live in Florida and I don't have to worry about that too much. But flat roofs should never be completely flat. There should be at least a little bit of a pitch to it so that the water can drain off. Standing water on a flat roof should be reported if you do see that. So the steeper the roof, the faster it sheds water. The flatter the roof, the greater the chance of leaks in the roofing system. If it isn't installed correctly. As inspectors, always, I mean this, always check and consider the roof slope when evaluating these systems because the condition of the roofing material and the looks for signs of moisture intrusion are all important and we have to always remember, like I kind of think of the house from the top down and then from the bottom up if people understand that. So there you go. So most the slope of the roof um I was sorry, lost my train of thought here. So the slope of the roof, it's funny because like on my house here, we have a flat roof and then we had shingles going right down to the flat roof. We had four contractors come out and tell me that I could put shingles on that flat roof. We had one contractor said he wouldn't, so he was the one that was hired. Because what ends up happening on that slope is we got a 612 pitch and it goes down to um, 212 pitch. A little bit less than that, but whatever. So the water, you think about it coming down like this, and all of a sudden it's all that water slows down here, and as it does, it's kind of like a hurricane blowing sand through the air, and it'll take those granules off, and then once the granules are gone, then the roof kind of gets compromised. So we ended up doing something a little bit different with an epoxy, which is we're very happy with so far, and that has like a 25-year lifespan on it. So if I don't do nothing. So when you're looking at shingles, a lot of times, like when I'm in the roof area, I will look at or underneath the attic space, I'll look at the nails driven through the plywood and see how they're sitting. Because, like, if they're sitting too much at an angle, I can tell that they have penetrated that shingle above it. So we want to make sure that the fasteners are pretty well lined up. I mean, they're not always going to be perfect, but as long as they're all pretty much the same. And I've seen it where one actually shot straight through the plywood and you could see laying through the shingle, and that's not never a good sign. It means that they've had too much pressure on their air guns when they're going through it. And if that does ever happen to you, make sure you just report it. If there's any damage and stuff, make sure that you're reporting this kind of stuff. So that's pretty much it on that one. I think if you guys want to read that, you're more than welcome to. You can always screenshot it too, don't forget. So the underlayment. Now, underlayment on the roof sheathing and roof penetration is the roof's backup protection. A few shingles are damaged or blown off or something like that. Water can eventually make its way through that second layer. So, however, it's not designed to be a primary roof covering for long periods of time. So we want to make sure that that underlayment is properly put on from what we can see. And so the roof sheathing, so if you think like the underlayment is that first section and then your shingle goes right on top of that. So no water should penetrate inside that um, underlayment. And here in Florida, we actually have this thing that's called wind mitigation, and we actually check to make sure that there is some sort of underlayment underneath those shingles. Now, the roof sheathing, the roof covering is only as strong as the wood sheathing itself. So if the sheathing is weak and damaged or poorly fastened or whatever, that's why it's really good to walk a roof because you can actually feel that under your feet. And I always recommend people when you are walking on those roofs to make sure that you kind of find the truss and then take your foot out, but keep one foot on that truss because that's going to be more stable than the sheathing itself. In areas where it gets frequent amount of hail, impact resistant shingles, the class 4 shingles, provide better protection and may even help the homeowners with their insurance benefits. So, anyways, roof penetration. Every hole in the roof is a potential for a leak. So you have to understand to look at like those plumbing vents, those exhaust vents, the HVAC vents, the chimneys, the skylights, anywhere that there's a penetration in the roof, you want to make sure that you're looking around there to make sure there's no moisture or staining or anything like that. A lot of times, like if I see mold, I'll just say there is some staining in the attic or what have you. The more roof penetrations, the more places water can find its way in. The fewer holes in the roof, the better chance that you're not going to have as many leaks in the roof. So during an inspection, I was just kind of pay close attention to that kind of stuff because it can really save not just you but your customers too. And that's the bottom line. We really want to protect our customers as much as we possibly can because when you're looking at like the roof penetration, we want to, check the flashing, and that's really important because that flashing prevents water from getting where it doesn't belong. So water penetration is commonly associated with the flashing and detailing problems around the roof penetration, eaves and your wall and intersections and stuff. The best practice is the flashing to be overlapped in the right manner. You want the bottom layer and then the top layer to go on top of that one, and then this one to go on top of that one. So it actually kind of steps its way down. The conceptual details of this is also found in the 2006 IRC, and you can check out the roof flashing area. And a lot of that's around your windows and doors and things like that too. And the more you understand how the flashing works, the better protection you're going to have in the house and the better protection your customer is going to have. So just kind of understand that flashing bit. So this figure is um, provides a model for us to how the correct flashing should be installed. The technique for asphalt composition shingles, which is the most common roofing material here in the United States, we want to make sure, just like I said, that it's flashed properly, it's put down properly, and then it's covered, and then it, it directs the water away from whatever it's uh, attached to. So like here where I live, we see a lot of flashing where the wall meets, like it's almost like a butterfly effect. We got one roof coming this way and one roof coming this way, and then I got another roof here and then the roof over on this side. And all that water is just pouring into one little section right there, and then it's diverted off there. And I always look for that flashing and make sure that there's a kickout flashing on the bottom of that so it doesn't go all the way down. A few times I've seen where they didn't have that kickout flashing, and it's just moisture staining all down that exterior wall, and it looks terrible. And not only does it look terrible, it's going to cause moisture issues later down the wall. So you want to just check all that stuff out when you're out there. And like I said, you don't have to memorize the stuff, but understand how water moves and how you can protect that house at any time. So this figure or this table here, it identifies the width requirements for the ice damming shield. So people up north, I've seen a lot of ice damming, especially when I was in Minnesota, and a lot of times that ice damming is not really caused by the roof material. It's actually caused by insulation problems. And so it kind of works hand in hand. If you have more insulation, the less chance you're going to have warm air escaping from that roof access and causing that ice dam. So we want to make sure that you get that 36-inch roll of flashing across there. And sometimes that's not enough either. It's that insulation in the attic that actually prevents a lot of ice dams. And yeah, just don't want ice dams. I'm so glad I live in Florida. um, Attic ventilation, just like I was talking about. So just because you have the insulation, if you don't have the right ventilation, it can cause problems too. So it's a combination of everything in the house that can cause moisture-related problems. And controlling that moisture and condensation will help keep your attic cooler in the summer, and it'll also keep your energy bills down, and it'll help prevent those ice dams in those colder climates. So proper ventilation removes the heat and moisture from the attic. Just yesterday, I was on a brand new build, got in the attic, and they had the the vents actually covered on the top. So it's like, oh, people, you forgot to cut holes where the vents are going. And so it was hot as hot can be in that attic. So proper ventilation removes that heat. And we want to see that, as it moves the air, it's actually going to help cool down the shingles too. So one thing to remember is that ventilation alone won't solve the problem. If warm air leaks into the attic space through gaps and light fixtures and things like that, plumbing vents, whatever, um, it can overwhelm the whole ventilation system. The this warm air can cause, like I said, the ice dams, mold growth. It can cause a lot of issues. And ice dams, for those who don't know what ice dams are, I know a lot of people are from up north, so ice dams form when that heat escapes into the attic, just like I said, and it melts the snow, and then the snow refreezes, and then it forms kind of a dam, and then it actually thaws and freezes and thaws and freezes and thaws and works its way up underneath the shingle and then causes some issues. Uh, Good insulation, like I said, keeps the heat in the house, and that's where you want it. Good ventilation removes heat and moisture from the attic. It's pretty simple. We don't want to add any extra moisture if we can help it. So now, when we're looking at roof systems and the overhang, sorry, I just thought of something my friend said. I love the way you say roof. I'm like, yeah, I'm from up north. Roof overhangs and projections, such as like your porch roofs and your overhang upper roofs, provide primarily um, means to deflect that rainwater away from the building walls. The potential for water penetration through siding, windows, and doors is minimized. So, because the protection of the roof overhang increases with increasing overhang width, larger overhangs than recommended in sections may be important in consideration when the water resistant wall barrier design is. So that's what this is basically protecting. Sorry, I was reading that and I kind of got a little. So basically, what I want to talk about is like your roof overhang offers limited benefits during periods of severe rain conditions, especially wind-driven range, such as like your thunderstorms and stuff. And in severe wind-driven rains, a good performing weather resistant barrier for the walls is least as important as providing that roof overhang. That's why we like to see at least 1 foot overhang so that you actually control that water so it gets away from that foundation. Because the bottom line is the roof is designed to protect your house. When the overhangs are not as wide, it doesn't seem to do such a great job. Same's true as with gutters and stuff, and we'll kind of talk about that in a little bit. So, um, and so when we're talking about the gutter systems, a lot of times people tend to fall short on on how gutters should be put. So, like if if you're looking at gutter system, the rule of thumb is every 30 feet you should have a downspout. So the roof overhangs help with that rain water, while gutters and downspout collect that water and push it where you want to control it. So it's not just dropping on the ground. And you can see, like, when you go into a lot of houses, when you're looking at the landscape and stuff, you can see right where the water line is, right in the grass area. And it's all because they're not controlling the water. The water is just going wherever it wants to go. So gutters are have to be securely attached at increments, and they have to be free of major damages. And of course, you want to look and make sure there's no debris and stuff in there. Like I like to say, a herb garden up there. because you don't want, vegetation's growing on your roof, and that'll actually cause moisture too. I've seen where vines are actually growing out of the gutter into the roof system underneath, and it's like, wow, you couldn't see that you had some tomatoes growing up there. It's crazy stuff I've seen. So you want to make sure that gutters are put on and they're free of debris, and they should be at least like 4 to 6 feet away from the foundation. And just dumping into the corners, that will cause moisture issues and foundation issues. So we want to make sure that it's spread out and it gets taken away from the foundation. And that's why a good landscaping swale and stuff should be added in there, or maybe even a French drain or something to that effect, so that you can control that water so it doesn't get into your foundation. Last year I had a customer call me and said that she had water in her house, and I said, "Well, do you have gutters on your house?" She said, "Yeah, I got gutters. I did this, and this." She was kind of mad, but anyways, I went to her house, just looked at it. Turns out she had a gutter system, but all the downspouts were 100 feet apart. And it's like, well, no wonder you're getting moisture intrusion, because you're not controlling the water, and there's tons of water right here, and you can see the slope of the land is all going towards the house. So be kind of cautious about that stuff. It's just gutters collect the water, the downspouts carry it away, and that's basically all it is. Control that water. So the residential code of 703, the exterior covering. So this slide here is a section that discusses what a home inspector really should look for when you're looking at the weather resistant wall envelopes, and which it can include siding, it can water barriers, all that kind of fun stuff. Current U.S. building codes don't distinguish between the inherent performance differences of each various weather resistant stuff. So, in addition, selections of the siding system generally focus on what it does. And so when you're looking at this, just because we're saying code, we want to make sure that we're understanding that the wall system is installed properly, so that the basically you're not getting a ton of water through the wall exterior. And like I said, with that one lady, I mean, she said, "Well, I got a block house." Well, you got a block house, but it's not water tight; it's water resistance. So that's kind of the difference that we want to look at whenever we're doing any type of inspection. So, uh, due to the potential for that water accumulation in that wall cavity, a water-resistant membrane must be installed behind any exterior siding and that veneer. So if you're having any type of, fake rock or something like that, there should be some sort of water-resistant membrane right behind there, so that it doesn't get through the wall. And all the building code basically says that you have to have one layer of number 15 asphalt felt or other approved water resistive barrier. Now, things are going to change in the future, and just because this says it now doesn't mean that it's not going to change later on. And so understanding the code does give you a good understanding of how houses should be built on today's standard versus 20 years ago when it wasn't installed that way. The installation is most effective when you understand how water moves. And like I said, water always will find the least path of resistance. So, and for as long as 100 years or more, depending on the type of material and climate, maintenance really does put a big factor in that. So we want to make sure that you're understanding that your, let's say, like your cladding system and your flashing and your caulking, especially around all those penetration stuff, is put up right. And it's really good to call out when you see stuff like that, because it is a potential for water intrusion in your house. So um, it's just, water is just one of those things where it's gonna be there. We have to be as inspectors looking for where that water's coming in. And a lot of times it can be difficult, especially when you're new in this. And a lot of you new home inspectors, I recommend like you start like with Habitat for Humanity or something, help build houses so you understand how houses are built. And if you do understand how houses are built, it gives you that upper edge to understand how the siding, the moisture barrier, and all the sheathing and everything, and how things are put together so that you have an understanding up here when you go talk to your customers. So number one thing is, try to keep the weather on the outside because we want to keep it controlled on the inside. These are climate conditions that are categorized on basically the coast here. And if you look at the map here, it'll actually like it's good to understand the where the wind-driven rain is so that the barrier systems are designed appropriately. So like up in Minnesota, we didn't really have the wind-driven rain like we do here in Florida. And so it's on the East Coast too, they get that wind-driven rain. So we want to make sure that proper eh, um, techniques are used in those areas, especially when it comes to the homes that you're inspecting. So determining moisture resistant wall systems is uh, super important. Uh, Step one is to understand where it is. Step two is to assess the building exposure. Not every home is exposed to the same weather in every state. So a home located and designed somewhere else might not get as much wind-driven rain as one that's here. So uh, you want to make sure that the the roof overhangs are right. You want to make sure that trees nearby are going to block some of that wind, so that's good. But it also could be a problem too when you have the big trees and stuff because they could actually blow over. So you want to kind of be aware of things, what could cause moisture and what is causing moisture. Homes with little or no roof overhangs uh, can be a problem in some areas, and you might want to check for moisture more often, like especially like on your mobile homes and stuff, because they only have like a 2-inch overhang because they got to drive down the road and they can only be as wide as they can be wide on the road because I think it's 100 inches, something like that. And so check those walls because that's where that moisture intrusion can happen. So the more exposed a home is to the wind-driven rain, the greater chance for moisture problems. So we want to make sure as home inspectors that we're understanding where and how water moves. And like I said, here in Florida, I mean, all of a sudden it comes at you and it's like it's hitting you from all like from the front of you, and it's like, is that rain supposed to come from the top? But it feels like it's actually coming right at you. So it always depends on the system that is on the house, how the building envelope is actually designed, and when you're understanding the exposure to the elements, you got to understand protection, how to protect that house, and how certain systems work better in certain areas versus where it works better here. It might not work as good up north or maybe in Ohio or maybe over in Utah or something like that. So we want to make sure that you're understanding your area where you're doing home inspections and giving them the best advice possible because like I tell people, I'm from Minnesota, so things are different from Minnesota. Yes, it's the same standard, but it is different systems on how they build things, understanding flashing. So based on building exposure, the level of determination is or level is determined the building. Let me start that sentence right over. Based on the building's exposure, the level is determined in step two, WRE, which is said right on that sheet there. The approach is different, and alternative other factors may be reconsidered in certain areas too. And I hope people understand what I'm trying to say here, but basically protect your house, protect the house that you are inspecting, understand how it's built and how moisture moves through those wall systems, especially with those wind-driven rains. So if an exterior wall repellent coating to masonry is apparent, you may want to pay close attention to the face of the product to make sure there's no spalling or any bubbling going on or anything that's moisture related. Often the wrong product has been applied to that. So it's something that kind of off topic, but kind of goes on this is back in the day when they would build wood boats, what they would do is they'd actually take cloth and then they would paint the cloth and then they would put the cloth on the boat and then they would paint it again and paint it again, paint it again. And that was to keep it from getting the wood boat wet on the inside of the boat. So if you ever wanted to build a boat, you could actually just basically paint a boat. So, and the same thing's true with your house. You want to make sure that that water that is on the outside stays on the outside. And if you're not using the right type of paint or the right type of material, it's gonna make its way in. That's all there is to it. Even a masonry wall, like that lady that said that she was having moisture in and it was a gutter problem. It was it was a block house. It shouldn't have had moisture in there, but that hydrostatic pressure and thermal expansion made it possible for that water to get into the house. Excuse me. So there are three major areas in a house around doors, windows, and any type of penetrations. And there are three major windows and frames, such as you got your wood frame, you got your vinyl frame, and you got your aluminum frame. Windows and doors can be a key contributor to that water penetration through the walls, and either it isn't flashed right or it isn't put in right or caulked in place. This can actually cause more problems if it's not installed properly. I put in a window once that I didn't caulk it properly, and we had some moisture issues, so I ended up removing the wall. And sure enough, it was right where I had just a little bit of caulking that I should have smeared it in, and I didn't. I didn't. I don't know why I didn't, but whatever. Without careful installation, you're gonna have that moisture problem, and some leaks will come through. Water will always find a way. And when you're taping up the exterior of a window, let's say like this is a window, you always want to start at the bottom, then put your tape up on the top, and then tape the top of it. And that way the water just sheds completely down. And that's the way it should be. So simplifying this is kind of what I want to focus on because a lot of people don't understand that you can't just put up a window and just tape the sides and the top and the bottom. Well, moisture might get in underneath, so you want to do it in the proper fashion. So if the life expectancy of the windows and doors also pay a big contributor to how much moisture is in there. So like I remember doing a wood frame window and the whole bottom of the sill was completely rotted out. And after we removed the sill plate on there, we found that out. So there's been a few times where because I've worked in so many different fields, it's nice to know how things are put together so that I can really relay that to the customer, and I want to relay that to you so that you can be a better inspector. And so a lot of these windows and doors only last 10, maybe 15 years, some of them even 50 years plus, depending on the type of material it is. So like the vinyl windows, I believe those are 50-year life expectancies, but again, you got to check out the maintenance on it. There's caulking there. You have to seal it. You have to understand how the window actually performs and how it should be put in. And many units have weep holes, and sometimes people will actually caulk over those weep holes, and all of a sudden you got moisture coming in through through the wall because people didn't realize those were supposed to be there, and they think it's a place where bugs can get in. Well, water is much more uh, invasive than a lot of bugs. Not all of them, but you just want to keep that your building envelope sealed. So high performance windows really are. really cool because they have the system in place for getting shedding the water, and it's like a rain screen system. So as we as like the high performance windows, they can they can really handle that severe wind driven rain. They can have the high exposed um, uh, ultraviolet light and things like that. So you want a good window system, and a good way of looking at that is like when I'm doing home inspection and with our wind mitigation course here, you'll look up on the top of the window, and a lot of times there's like a little sticker, and it'll actually teach you what type of window that is and how much uh, how much that window can handle, especially with that force driven rain. So look up on the next time when you go to a home, look at that, or where the etched glass is, it'll actually tell you what type of window that is too. So it's good to know these things so that you can inform your customers, and it makes you sound pretty cool too. It's like, oh, this is a high performance window. It's a gold sticker, kind of thing. So water penetration and it can happen when things aren't flashed properly. And flashing is very, very important when it comes to any type of openings or where a wall meets a roof or anything. So like it's when I'm looking around, that's one thing that I'm looking at is the flashing, how it's installed properly. And water penetration can accumulate in walls that aren't flashed properly. So we want to make sure that flashing is put in properly. And a lot of times, like what I recommend a lot of new home inspectors do is go to like a Home Depot or a Lowe's or whatever Ace Hardware or something and look at the flashing that they have and understand what type of flashing is what, if it's Z flashing, L flashing, whatever it is. And so that you can understand how it looks before it's installed. So that way you can visualize it when you're looking at that roof or you're looking at the window and understand how it is. Now, like they make this flex tape, and that's pretty much the same thing that they use around windows and stuff. And if you're doing new construction, zip board, they use um, zip flashing and tape around certain areas, and they use a stretch tape, and they got all this new technology that works really well, and it's all flashing. And so we want to make sure that exterior walls and doors are flashed properly with the tape or the metal flashing or vinyl flashing, whatever it is. And especially like up on your roof, make sure go around that chimney and make sure that there is flashing all the way around. If you can't see the flashing when you're underneath in the attic, make sure that you're looking up around that chimney because I can't tell you how many times I've been in houses where the chimney was not flashed and there was water intrusion, rotten trusses, and where I could stick my finger right through the truss. And I don't recommend doing that because it's not a good thing to destroy someone's house when you put your finger through stuff. But if you can see it, take a picture of it, send it on there for their evaluation from structural engineer or whatever it is. So, and when you're looking at stucco, there is a great course that InterNACHI actually offers on stucco, and I recommend everybody take that one because you'll learn a lot about where flashing should be in the coping and things like that. So, anyways, uh, yeah, let's go on the next slide here. So the flashing of the wall components, we always want to make sure that the flashing is installed properly. I totally forgot I had some flashing out my shed and I totally forgot to bring it because we had some technical difficulties here. But anyways, what I can do is like if you're looking at any type of flashing or tape or anything, you'll notice that there's one edge that goes this way and one edge that goes this way. Sometimes it's diverted like this or whatever. And you want to make sure that it's properly installed and you want to make sure that you see it. And so flashing of the wall components, especially like if you have a veneer siding or anything, you want to make sure that there's at least one up on the top. And then as you're looking at like if it's brick or something, you want to make sure that there's weep holes so that if there is water that gets behind there, that it has a way to get out. And if you look at like they have like these cotton threads that come out, and that's for weeping out the water from the backside of the veneer. So that's what you want to kind of look for. And if you don't see that, and you do see some water staining and stuff on the bricks, just kind of make a mental note when you're doing your home inspection inside the house that you're going to check that area really thoroughly. So it's kind of what I've learned. And like I said before, caulking and sealants, that I always tell customers, you should just buy a box of caulking because you're going to need it. When you buy a house, caulking is one of the most important things that you can do to help prevent water intrusion and and sealants, of course. And like I have a RV, and what I did is I used some 3M marine caulking and did all my seams with that. So it's good for 5 years, and I'll have to do it again in the next 2 years here. But because of the caulking that I used, it's actually going to prevent that moisture from coming into my camper. So that's why it's so important when you're parts of your homes, these to make it water resistant, especially on that envelope, because it helps seal those joints and the gaps and where the water and air can enter. You want to try to stop that or minimize that as much as you possibly can. And that prevents water intrusion. And proper flashing is always the better long-term solution. With caulking acting as a secondary line of defense, it's kind of like your roof and your secondary layer there. You want to make sure that everything is working together so that you have a great system in place. And over time, of course, caulking will dry out. Just like I said with my camper, it lasts about 5 years. I'll have to redo it. It'll shrink. It'll start deteriorating. The ultraviolet light's gonna affect it. And as home inspectors, when you're going around those windows and doors, make sure that you're looking at that caulking. And if you see that it's discolored or that it's starting to crack and stuff, you might want to say further evaluation from a handyman, or you might want to make sure that they're understanding that this can possibly be a moisture intrusion area. So you want to check with your moisture meter or your thermal camera, make sure that there's no moisture getting in there, especially around like your plumbing joints and things like that. Anything that's coming through that wall. And there's also different types of sealants that you can use too, like silicone or polyurethane sealants and things like that. And each one has a different grade of what they're used for. So I do recommend that you do some research on each one of these type of caulking. And what I do is I actually have a little section in my report that talks about all the different types of caulking and what they're used for. So like silicone around for bathtubs and sealing up doors and stuff on the interior. And there is just so much information that you can use. And again, go to one of these hardware stores and look at the caulking and just kind of read what it does and what it's made of, if it's paintable, if it's not paintable, if it's silicone or whatever. So think of caulking as just a maintenance tool, and it's not a permanent repair, but it does help keep water out, and it'll help seal up those gaps and stuff, especially in that winter time when air gets through. So caulking, very important. So now we're going to talk about the moisture resistant foundation. And many sites are considered normal and fall within the standard condition addressing in the residential codes. However, the use of marginal sites, which is becoming more common, because without the proper site design, can result in costly mistakes. So when you're looking at foundations, you're looking at the landscaping stuff, you got to make sure that it is properly elevated. So like I was called out to do a phase inspection on this report or this house, and there was a drop off within 10 feet of the building. And I said, I'm I'm not liking this. I mean, you walk out 10 feet and it's a complete drop off. They said, oh, they're going to do the foundation a little bit deeper. I said, a little bit deeper. Okay. Yeah, they're going to drive it down another foot. Well, that may or may not um, be what's called there, because I don't know the soil grade. I don't understand the drainage system that they had in place as they're building this. So I just had further evaluation. Well, turned out the whole entire section of where I was inspecting actually it cost them, I believe it was $100,000 because they had somebody come in and say you can't do this, and actually protected all those houses on that whole ravine basically. So when a house is built, the site plan should be developed for that location too, and it can cause some major issues if it's not properly drained right, if it's not properly designed properly, like the footings, yeah, bringing it down another, foot might have helped. It might not have, because once, soil erodes, it can cause some major problems. Back, I believe in the Dells over in Wisconsin, they had a house that actually fell from a ravine because it was too close to water, and they had so much rain and water that it actually fell. So uh, the model building standards typically require a minimum of 6 inches of fall in a ground level over 10 feet. So I drone, I forgot it was there. Providing additional slope is a good method to offset the future settlement in that whole landscaping area. So you have to look at the site drainage when you're looking at foundation, because that's very important. And the wetness factor can really cause issues if it's not the right condition. So like if I'm here in Florida, it's a lot of sand. So sand moves pretty easily when it gets wet. Up north where I was originally from, there's a lot of clay and the soil stays in place. And so it all depends on where you're building these houses, how the landscaping is. You want to make sure that that slope is away from the house, but you also want to make sure that the slope is slopey enough instead of having it just drop off, because that could cause problems too. So just kind of keep all this stuff in your head as you're just walking around the building. And I always recommend, like when I do my home inspection, I walk around one time this way and then I walk around the other way because I might have missed something. So that's why I do it the way I do it. Anyways, um, and you just keep an eye on that, how the building envelope is and how the landscaping is around that house. And if you see something, say something. It's that simple. So when inspecting basement foundation, I kind of miss doing basements here in Florida. There, I've done 5 of them now, and so it's not very common that you see basements anymore. But I do kind of miss people's basements because there was a lot of cool things that I'd see in basements. Found a lot of secret rooms, things like that, and I also found a lot of moisture issues. So one of the biggest places we find moisture problems is around that foundation wall. And remember, the foundation is always in contact with the ground, and the ground always has moisture in it. Matter of fact, concrete always has moisture in it. As inspectors, we're looking for anything that involves water getting into the home. That could be through cracks, foundation, that's poor grading and clogging, gutters, or whatever it is. The signs of water is always present. And if it's been collecting a long time around a certain area, you should be able to see it. That's why I say if you take 4 feet at a time, just, 4 feet, look up, look down, make sure that you're really paying attention to where things are. That's why when you're doing these home inspections, you want to make sure that you're doing it um, for the benefit of the customer. One thing I always tell people is that water follows the path of least resistance. You heard me say that before, and it always finds a way. If the ground slopes towards the house, you're gonna have some sort of moisture issue. You're gonna have some sort of water issue if it isn't properly drained. And that's why we want like the drain tile, things like that in place. Good grading really helps get rid of that water, and it's just the way it is. And water will find the path of least resistance. Even if you damp proof things, um, and you slow that moisture down, but waterproofing is designed to keep water out. There is that high water table too that has to be understood too, because if your water level is up, that's why you want the drain tile in there and your sub basket to be there. So don't be surprised if you see small shrinkage cracks in concrete foundations, or um, That's common. You're going to see effervescence, damp areas. You're going to see staining and stuff on the walls because of the wall is permanently in, outside. So, uh, or inside the ground. So at the end of the day, it's much easier just to keep the water out, just keep it away. And that's why grading, drainage, and all that fun stuff is really important on every inspection. Just keep an eye on that, especially you people that have basements, because basements can be problematic, but they're also a great commodity to have. I kind of miss our basement. So when it comes to basements, new construction and existing homes are a little different. New homes can have installation installed on the outside of the foundation. This actually helps control that moisture and also helps that frost too. So when the ground freezes, it contracts a little bit, and then when it thaws, it expands. And so if you put that little bit of insulation there, it'll actually help buffer that a little bit. And if the basement is finished, moisture control becomes even more important. So moisture gets trapped behind that finished wall, and it can lead to mold, it can wood rot and damage that you can't see. That's why it's always important to really take your time when you're doing these home inspections and look for little clues. I believe that every single house is telling you a story, and you just got to tune into that story so that you understand what that house is doing. And as inspectors, we have to pay close attention to this. We don't want our customers coming back 10 years from now and saying, or 10 minutes after they buy the house and say, hey, we had some moisture issues because you didn't want to look at the landscaping and you didn't realize that the basement was right close to where the downspout was or something. So if you smell something or see something staining and stuff like that, it's a quick thing to just put in the report, say, it appears to have some sort of distinct moisture or uh, smell in the basement, further evaluation. And that just kind of helps you relate that to the customer so that you can protect yourself. So remember, insulation alone won't solve moisture problems. Good drainage, waterproofing, air sealant, and humidity control all work together so that it can keep the foundation where it's supposed to be. And covering it with finished material only hides problems. And you're going to see that throughout your lifetime of inspection. Like you'll look at the ceiling and there's a big dab of real fresh white paint. Well, that doesn't tell me that there's any type of problem there. And it might be a path problem, but it, you see it, and just make a note of it. So, when you're looking at slab on grade construction, and there's a lot of slab on grade here in Florida, um, it's monolithic and stem wall construction are generally simpler than basements, but the same moisture control principles still apply. Everything has to apply the same because it's connected to um, the ground. And as inspectors, it's important to understand how the foundations are designed to manage moisture so we can recognize those defects and identify potential moisture intrusion. The better you understand proper construction, the easier it is to diagnose moisture problems during that inspection. So if a vapor barrier of 6 mil poly or equal um, vapor retardant is generally required below any slab, uh, and so that the joint should be lapped over, it should be taped at least 6 inches, and all this stuff really needs to be put in place, especially if a lot of your home inspectors that are actually doing these phase inspections, make sure that the vapor barriers put on first before they pay that or before they pour that cement. Matter of fact, tomorrow I got to go out and do another phase inspection for a guy. Um, but when you're looking at the vapor retardant, you want to make sure that things are separated. So, and that's basically what it does is it separates that earth from the cement so that it doesn't leak up. And it's a capillary break layer, basically. Generally like 4 inches of clean grade sand, gravel, crushed stone, whatever it is. And it further prevents that soil moisture from wicking up into the bottom of the slab. A lot of times you will go into older buildings like garages and stuff, and after it rains, and you'll see like it's sweating, and the whole entire slab is sweating because there was no moisture barrier back then. They just poured it on and left it. So you want to make sure that it's damp cured, basically, and then I forgot what I was gonna say. Uh, you want to make sure that that layer is there, is basically what I'm trying to say. And that capillary layer below the slab is put on properly, especially those people who are doing those phase inspections. A lot of inspectors have stopped doing them because they're just hard to get into, but I still do them. Concrete slab and cracking. Now there's two types of concrete. There's concrete that's cracked and concrete that is going to crack. It is a normal part of the curing process of concrete. And I've heard, and I'm not 100% sure on this, but concrete actually cures better in water. And I'm not 100% sure of that. Some people tell me it is true. Some people say it's not, but that's what I've learned. The goal isn't to eliminate the cracks, it is to control where the cracks are. And I am a big fan of joints that are actually put on before the concrete is actually cured. A lot of times they go in after the fact, but I believe like the concrete has already settled where it's going to crack, and it helps relieve that crack, but sometimes you'll get it right across. So builders use reinforced concrete, or sorry, reinforced rebarb to help minimize those cracks. And so we want to make sure that um, the concrete is put, uh, the concrete has to be put properly around the rebarb, around the entire foundation area, so that it's that it allows for um, I just totally lost my place here again. So it when you're looking at concrete, it's going to expand and contract, and it has to do that, and it does move. And you got to think of this planet moving at 900 miles an hour. Your foundation is moving. So if you have the rebarb in place and you have all the concrete joints cut, it's going to move, it's going to crack eventually. And we want to make sure that it's cracking in those joints. And it's not a bad thing, but if you see some concrete that is lifted up on one side and dropped on the other, you got a problem. A lot of times, like when I'll do home inspection, I see that, I will bang on the concrete with a wooden tool and hear the echo and see if there's any gaps or anything underneath that concrete. So too much, and that can cause problem too. So too much water added to the concrete mix can actually weaken the slab, and not enough water could do the same thing. And um, we want to make sure that concrete's put up right, and in that vapor barrier, and that that water vapor is not going to come up, and radon gas for that matter. For I know a lot of home inspectors do radon mitigation systems and test for it. So that's a good thing to understand, that that vapor barrier actually helps prevent a lot of that uh, moisture from coming through, but it also helps with radon gas and stuff. And as inspectors, don't just look for the cracks um, that are obvious, but kind of, you know, look for the staining, look for the shrinkage, look at displacement, and, just pay attention to what you're doing. That's basically all it is. Building codes allow foundation installation to be placed in various locations at perimeter of the slab on grade foundation. So ideally, the best location for installation is slab on grade foundation is on the vertical outside face of the foundation. And that's pretty much it on that. So let's move on to the next slide. Slab on grade insulation and finishes. So carpet and wood floors. That's a big one because I see it quite a bit, especially where I live, that people will put wood right over concrete. And if it isn't properly put in, you're going to have some problems. So concrete may look dry, but it still contains a tremendous amount of moisture, and it wicks from the ground. And the moisture can wick up through the slab, and even over years, it finally, makes its way through. Because of this, carpet and wood-based products should be installed shouldn't should not be installed directly on the concrete slab without proper moisture barrier or underlayment. Now, if moisture is allowed to wick through the materials, it can cause, your carpet padding to stay damp. Mold and mildew. We don't want to see that. We don't want to see the musty odors. Or how many times you've been to an old house and you walk in the door and you're like, "Ooh, it smells like old people." We don't want that. Um, Hardwood flooring tends to swell, or it's like sometimes cups up and it starts to warp. And engineered wood or laminate floors tend to separate or buckle, and adhesives actually fail over time and cause flooring to be loose. So tile and decorative concrete generally perform much better on the slab on grade homes, and now vinyl too on top of that. What inspectors should look for is, when inspecting a home with a carpet or wood flooring over the slab, watch for the soft spongy spots. Check for staining, check for discoloration, check for those musty odors, and the high moisture readings along the exterior walls. That's why I like, when I'm doing my home inspection, I do the moisture meter all the way around the exterior walls. You want to look for effervescence. If you see any, just call it the way you see it. Concrete isn't waterproof. It's water resistant, but it isn't waterproof. It's like that sponge that we were talking about earlier. It pulls moisture from the ground, and eventually it will make its way into the house. So we want to just make sure that we're checking on all the different areas of the foundation. That's the easiest concept I can think of, is, just take your time. That's the best advice. My boss used to tell me, Dirk, just slow down. And it's helped me identify a lot of problems in the years. So just slow down, take your time when you're doing home inspections. Try not to be in a rush. Sometimes those realtors will get on you, but slow and steady wins every single time. So when you're looking at crawl space, and we had a couple of comments earlier about crawl spaces and ventilation and things like that, and so I'm just going to tell you what what this is all about. The primary cause of moisture problems in crawl space are poor site drainage and the lack of ground vapor barriers and the ventilation during humid summers. Crawl space moisture damage and mold formation can be a cause, or can be caused by issues that are all related to um, your poor site drainage. And when you're not identifying these systems as you walk around the house, when you get into crawl spaces, you should be seeing it then. Okay, so ideally, crawl space construction should result in an interior ground surface at or above the exterior finished grade. Extra attention is needed for foundation drainage with crawl spaces below grade. Venting crawl spaces in humid conditions can cause condensation on cool surfaces, and including ductwork and floor framing and things like that. So potentially this could lead to water accumulation, and we don't want to see that happen. And if you see wet insulation, make sure that you are reporting that, or mold or anything like that. And I always tell people, if you're going to call out mold, don't say mold, say there's some sort of microbial growth or something like that, because that will kind of protect you a little bit better. Ground cover laid on a crawl space floor can become damaged over time, and that reduces that effectiveness that it was once designed for. So as as uh, like when you're looking at the covering, make sure that you're looking at it with inspector eyes. I don't know how else to describe that. So when you do see like tears and rips and things like that, be cautious when you're going into crawl spaces. A lot of times I will wear special gear and stuff when I go in there. I also have a crawl bot that also helps me navigate the crawl spaces. And if the crawl space is elevated, or if the crawl space's elevation is below the interior finish grade, foundation drainage and damp proofing, such as like your bituminous coating or some sort of moisture barrier, should be applied. Crawl spaces should use these measures along with external drainage systems. That is so important. And just manage that water. And so the ventilation is, so some people are for the ventilation. Some people are against it. I'm for it, depending on where you're at too. And I really believe that you should have vents on there, but you should have the vents that you can close if you needed to. And that's, I think that's the best system. And if they're automatic, that would be even better. Traditional ventilation calls for a minimum net area of at least 1 square foot for every 150 square feet, or reduced to one thousandths when you're using class 1 vapor retardant. So vents should be on at least 2 opposite sides of the foundation so it can breathe properly. Your house needs to breathe. Your crawl space, I believe, needs to be breathing too. And non-vented crawl spaces are also recognized as suitable, especially in hot, humid climates. And I don't really agree with that, and I don't disagree with it either. So I'm kind of neutral on it. And just like home inspectors, we are supposed to be um, on that um, fence about everything. So we're not going to be uh, putting ourselves out there and saying, this is the way, this is the way. What we're going to do is we're going to tell them the way we see it. You're asking me for my opinion. That's what I'm going to give you. So functional exterior grading and site drainage. You want to make sure you're looking for those factors. You want to look for leakage between and under around that crawl space. Um, and then insulation, you want to make sure, like if you're using the rigid foam or using 6 millimeter polyurethane grade, whatever, damp proofing, you want to look through all that stuff because it's gonna help you become a better inspector. Recent model building codes require a non-vented crawl space to be supplied with conditioned air and return air transfer grill or mechanically vented. And inspectors should check local codes and requirements when inspecting those type of crawl spaces. So, stay up on the codes because it can really help you understand a lot more about your area. And the disadvantages of having a vented versus non-venting, I think it's kind of a wash. And some people, agree, some people disagree, but that's why we have the codes in place so that they are the governing factors. And every jurisdiction is different. So many agencies will unwillingly to endorse closing the vents year round due to common moisture problems, soil type, whatever. And other areas will not. So it's get to know where you're at, where you're inspecting, and make sure you're trying to give your customer the best value you possibly can. So checking ground clearance. So de decay of common wood framing materials can begin when the moisture content of the untreated wood exceeds 20%. In foundation and building applications, these conditions should be avoided by adherence to minimum ground clearance and, of course, the detailing requirements. The ground clearance outlined in this section right here uh, are considered minimum standards or minimum techniques in climates where frequent rainfall or for sites with continuous moist ground conditions. Greater clearances are recommended, and it should be. Uh, the capillary break helps to protect wood from wicking up all the moisture from the ground. So we want to make sure that how it's set is right for the area that you're at. And so, like, even in some building required building codes require like a 6 inch minimum clearance between untreated and treated wood. Some of them have to have some sort of bearing plate or something to stop any type of wicking. So there's a lot of different variations that go within wherever you're living at. So most building codes require that 6 minimum clearance between the untreated wood and the exterior wood. Some codes allow 2 inch reduction clearance, a minimum of 8 inches of clearance between untreated wood in some areas, and in other conditions show this in figure 28 here, the ground clearance. So just keep an eye on what is good in your area and try to follow the rules. That simple. So checking wood preservation. Now, often there is a situation where wood cannot be adequately separated from the ground moisture or protected from the exterior moisture. These wood-based foundations sometimes, in these situations, either naturally decaying resistant wood or pressure treated wood must be used. In some cases, wood alternatives may be considered, such as like your plastic porch post and metal pipes inserted, plastic decking, whatever. The focus of the section is to identify proper specifications and use of preservation pressure treated wood to ensure moisture decay, resistance, and durable performance. Is what we're looking for. The recommendation in the sections are based on the standards and recommendations of the Southern Pine Council and American Wood Preservation Association, the AWPA. In recent years, changes have occurred, and the ability of certain wood preservative treatment chemicals for use in residential projects. So therefore, it's important to understand how these changes affect the treatment that's in the wood and the types of wood and application, and particularly the use of the CAA, the chromated copper arsenate. I can't even say that word, has been discontinued as a wood treatment, except in certain commercial settings. And so, however, there are exceptions to every rule in building. For example, the CAA treated lumber, plywood are still available for the use of permanent wood foundations, which is crazy to think this day and age we still actually have the wood floors, wood basements, or these systems are not specifically addressed in the course, except to mention that there are important foundation moisture management practices that should be followed, and the inspector should carefully consider manufacturer and industrial recommendation practices when it comes to all this stuff. The proper consideration and installation. These systems provide the driest um, area, the serviceable foundation system. So I've been to a couple houses that they've had a couple of wood foundations, and they're kind of cool, but I was scratching my head like, wow, I would do this, and this, but I'm not there to judge. I'm just there to inspect. So in the northern U.S., moisture vapor problems are driven primarily by indoor relative humidity, which is your RH, combined with the low outdoor temperatures during the winter. In the southern U.S., especially the southeast, the problem is largely driven by high outdoor humidity and low indoor temperatures during the summer months. Mixed climates are exposed to both conditions and can experience both types of these problems. Therefore, many of the best practices recommended in this section can vary according to the climate that you live in. The same is true of the underlying building code requirements. So every code is governed by the jurisdiction. Unfortunately, there is no defective and widely accepted climate map that addresses all climate factors. And it all depends on where you live. Various climate maps and um, can exist, like even in certain areas too. And like Florida just came up with a new map for their wind mitigation, and it's different. So things are always changing, and just like the world, It's always changing. And it's for this reason that we have to accept these practices and understand how moisture moves. And if you understand how moisture moves, you can really protect your customer with that. Moisture problems related to moisture vapor can be confusing because they can cause several types of moisture sources, and the result may differ from every dynamics in the house. Also, seemingly unrelated discussions that are made for one building system, such as how to lay out the HVAC system, how um, are not all independent and it can affect the migration of the water vapor in the house. So, like your high indoor humidity greater than 40% in the winter and greater than 60% in the summer is a general range. It it is primarily the cause of moisture related problems in homes because they don't have the condensation level correct. And so you want to get that relative humidity in the right order. And a lot of times, like I will send my customers a video on how to set their therm or their humidistat so that they understand what it should be and uh, in that area and what type of season you're in too. And when we're talking about the relative humidity levels, it is concerned because the whole house can uh, become too dry or it might become over humid. Uh, there might be too much humidity. So high levels of humidity is a concern too. So you want that sweet spot basically. You want to ride that fence as much as you possibly can because every climate is different. In the wintertime you want a little bit more humidity and the summertime you want less humidity and depending on where you live, because if you're down in Florida here, the less humidity, the better. And in the wintertime, it's kind of the same. But when you start moving north, it changes and you want to make sure that you feel more comfortable. And a lot of times that humidity factor actually will help you keep heat in. So if you think about like your moisture level in your house, every like molecule in that in the humidity will capture that heat. And even though like your house may be set at 72, but because the humidity level is higher, it'll actually feel a lot warmer. And so that's why the relative humidity is so important, especially in colder climates, and it'll make it feel more comfortable because the water vapor actually contains more heat, and your skin will actually feel like it's hotter than it really is. So inspectors should consider documenting the existence of any supplemental dehumidifiers or humidifiers in that case, and the presence of those should be documented and really try to, uh, you know, understand that too much humidity is bad, not enough humidity is bad. So controlling that really, you should teach your customers on what level it should be at. And, if you have any questions, you should always consider talking to an HVAC specialist and understanding a little bit more about that. Because air conditioning will actually remove a lot of the humidity, and sometimes it's too much, and sometimes it's not enough. So, understanding that in your area is really important. So get to know a couple of the HVAC guys because a lot of them will teach you this stuff and they know it like the back of their hand. I know enough to be dangerous on almost everything. So that's what it means to be a home inspector. A jack of all trades, a master of none, but still a master or better than a master of one. So air leakage can actually transport significant water vapor, and that can impact the moisture levels in the building. So to minimize these air leakage, these the building envelope should be sealed with an appropriate air barrier system. Considering climate conditions, home inspectors must understand air leakage dynamics. So if you're looking at this picture here, and unfortunately I can see it, but barely because I'm old and I'm having some technical difficulties. But the factors driven air leakage include like your wind stack effect, the forced air HVAC system. The air barrier helps my mitigate these issues. However, like sealing practices might reduce the combustion air supply for fossil fuel equipment, causing backdrafting or combustible products. Sealing combustion equipment and mechanical ventilations are recommended to address safety concerns and indoor air quality. The air barrier material must manage that vapor movement and it must shed that water. Um, and where the location is on the building also puts what I'm trying to say. The air barrier material can really make or break the whole system, basically. And you want to use the proper sealing materials. And we've already talked about the caulks and the sealants and the and we want to actually look at gaskets too around certain areas, especially around your HVAC equipment and penetrations through walls. And inspectors should prioritize major air leakage points. And that's what I like about the thermal camera. It'll actually, pick that up and you can actually take a picture of it and say, this is where this was. And, the plumbing stack penetration stuff. Our last house that we lived in Minnesota, we actually had a company come in and do a air quality test on it, and then they did a blow door test, and we found out that we had so much leakage, and it was an amazing system. It was before I was a home inspector, so I got to learn how the blow door worked, and then later on I took a course on it, and reducing that air leakage was it saved us a couple $100 a month. I mean, it was just crazy, and we had two air conditioners in that house too. So in the air conditioner didn't run 24/7. Then eventually we ended up with solar on top too. So we ended up saving a lot more money that way. But reducing that air leakage is essential because you're going to save not only money, but you're going to save moisture passing through with that air leakage. So, because that air, you know, will push that moisture in and out, and the effective air barriers such as like gypsum board and wall board or whatever spray, it it can help so much and get that air as tight as possible so the outside air stays outside instead of moving through your house. So it was funny because like I asked him like our insulation was so dark. And he says, well, you got so much air leakage in that wall that it's acting like a filter and it's taking all that black. All that black is actually just, it's not mold, it's actually just air movement through there. And yeah, I actually learned quite a bit from that guy. So it was pretty cool. So the air leakage and major moisture problems is very common in cold climates. So the primary concern in preventing interior warm and humid air from flowing outward into the building exterior envelope assembly during those winter months. The airflow can carry a large amount of moisture and cause condensations in the walls. Therefore, you gotta understand that the interior air barrier system in cold climates and very cold climates is preferred and may be a combination with that warm in winter vapor retarder. So we want to make sure that your system is in place and doing what it's supposed to do. And it's a viable part of your whole entire damp proofing your house. And so like when I'm looking at walls and even when we're putting it up and stuff, we want to make sure that everything is sealed as good as we possibly can. But we also want to make sure that you're breathing too. So there's that two types of things that have to happen in a house. The house has to breathe, but it also has to be damp proof too. And so scientists have actually done a lot of research on this, and they found that when they when you're looking or when they're observing walls, they understand like the moisture, how it moves inside and outside, and how it exchanges is really how moisture can affect your entire house. And I hope that made sense. But in like damp and humid climates, the primary concern is preventing exterior warm air from leaking into the exterior surface. So, or in through the interior surface, so that you, the air conditioner will actually, pull that moisture back out and put it out side. So in the damp, humid climates, the air barrier system is preferred on the outside wall instead of the inside wall. So many um, exterior sheathing products and wraps can provide this function. So the house wrap on the outside, and then you put that barrier on the inside wall will trap that moisture in there, uh, or it'll prevent that moisture from leaking through in colder climates. So that's kind of how it works. And like I said, it's really important that you understand that how systems are put together so the best practices are met. And we want to make sure that in the climates where it's mixed conditions, that it's put up for that jurisdiction area. And if you ever look at a house, and I recommend, like, go to a parade of homes and stuff in your area and understand how buildings are put together, because you got that the house wrap that goes on the outside of the house, and that'll really prevent a lot of moisture from getting through the wall. And then if you're in cold climates, you're gonna also want a level of poly on the inside wall so that it doesn't permeate through there, and then it actually the moisture will actually get out through the wall instead of inside your your interior surfaces. And that's kind of how it it works throughout all of America, is we want to just control that water and make sure that the water stays outside. In hot, humid regions, walls must dry towards the interior, and homeowners should avoid non-breathable finishes like vinyl wallpaper or vapor barrier paint. A lot of times, like when you go into modular homes and stuff, and they have those um, uh, you're looking at the vinyl wallpaper and stuff, and all of a sudden you start seeing mold and stuff because it can't breathe. And if it's not breathing, it means that it's gonna hold on to moisture, just like this cup. Or this thermos, it's gonna hold on to that moisture, and it's gonna cause problems. So incorrect insulation of the vapor barrier can cause really big problems too. And the air leakage contributes to that as well. And so properly installed vapor retardants provide that humidity within the building assembly. And we want to make sure that it's properly uh, put right. And us seeing it and describing it to our customers is really important. In hot, humid climates, exterior wall systems should dry inward by placing the vapor retardant outside and keeping the interior material uh, breathable or permittable or whatever. In cold climates, walls should dry outward by using vapor retardants instead inside the ensuring exterior wall. So I did have some house wrap, like I said, in the shed, but we had some technical difficulties and I forgot to bring that in, and I was going to show you what that looked like. Um, but like I said, go to one of these home improvement stores and look at the house wrap and touch it and feel it, and so that you understand how it actually works. It actually looks kind of like a tarp, and it'll keep a lot of that system or your air movement on the outside of your house, so it doesn't, penetrate your house. You want your house to be comfortable and climate controlled. So in this section here, we're talking about mechanical system moisture control. And here we're going to kind of go through like your duct work, your ventilation, common moisture issues that can arise, and the common rule of thumb sizing of your air conditioning system. So, such as like 1 ton of cooling per 400 to 800 square feet. And so if you got 1,000 square foot, probably 2 ton or a ton and a half or whatever. It all depends on the calculated load. And you can get this free online. You can just type in Google, load calculator, and you can find out what size air conditioner acceptable for this. Like my house here had a 5-ton unit, and looking at the size of this house, it should have never went over 4 tons, and I ended up with moisture really bad around inside my air conditioning hand or my air handler, and so there was mold all over it. And the guy that could replace it actually said it's the worst that he's ever seen because it was running too much air through the system, and it was causing it to condense inside that condenser, and then it was not draining properly, and it ended up having so many issues. And so when we replaced it, we're very happy, and now we can actually breathe a lot better too. And it's not uncommon for a home inspector to find clothes dryers vented into the indoor areas or into the crawl space or something like that. And not only that's a fire hazard, but it's also a lot of moisture that can build up in those areas that shouldn't be. So we want to pay close attention to all that kind of ventilation, the HVAC system, so heating and ventilating. So we want to make sure uh, that's properly put on. There's other things like your bathroom vents and stuff. A lot of times they'll go out to the soffit. I'm not a big fan of that. Um, but I'd rather have it go out the soffit than in the attic. And I see it in the attic almost, I would probably 75% of the time. And we want to control that moisture, get rid of that moisture. Therefore, when you're looking at duct work and stuff, that it's properly, placed, and there's not too many bends in it and things like that. So you want to just check all this stuff out and make sure that you're keeping up with the latest standards when it comes to HVAC. And InterNACHI also has a really good HVAC course that I recommend everybody take. And so we're going to go on to effervescence. And effervescence is one of those words that after I learned it, I've never forgot how to say it. And it's that white chalky powder. And someone told me that if you lick it, it tastes like salt, but I don't recommend doing that. I have not done that, and I'm not going to do that. But effervescence is a dissolvent of salt deposits on a surface or of a material such as concrete or brick or anything that's porous like that. The moisture that creates the effervescence comes from the ground, water, but rainwater can also cause this to be a source. And a lot of times you'll see that in crawl spaces and you'll see it in basements and stuff, especially ones that weren't designed for habitation. So you want to make sure that you're looking for that effervescence. If you see it, just call it out and just say, hey, there's some effervescence. That means that there's a little bit of salt and water mixture in there, and further evaluation. Building materials such as concrete, wood, brick, and stone are porous materials, and you're going to see that it can absorb or wick water, and water will move through the porous materials, and salt can be drawn with it. So concrete, wood, brick, stone, mortar are porous materials. So keep an eye on those uh, areas whenever you're doing home inspection. I did a house that was 19 was it sorry 1860s, and the whole entire basement was full of effervescence. Of course it wasn't inhabitable or nothing. There was a but it was pretty cool, and it's like, I don't know, kind of creepy at the same time. And it was all built by like old stones and stuff, and just effervescence everywhere. So just called it out. Just, it's effervescence. Like I said, I like to say the word. Um, so when you're looking at the capillary flow of water, when you're looking at the building material, uh, the evaporation occurs and it kind of leaves that salt residue behind, and that's what real effervescence is all about. It's just moisture and the solid. It's kind of like when you put a pot on the stove and you forgot about it when it had water in it, and then you come back and there's like that white chalky stuff. That's pretty much the same stuff. Um, but yeah, I don't think we really need to go in too much detail about this one, but that's basically what this slide is talking about. Um, to, so I don't know why I didn't think we had a video on here, but apparently I left that one on. So let's see if it actually works. Actually, oops, sorry. Let's go back one. This would actually shows how water wicking actually goes up, but the video doesn't work, so I don't think. No, anyways, water management and damage prevention. This is designed to help prevent moisture intrusion. And if you look on the left side of the picture there, or right, however you're looking at it, it shows how the water can come back into the house. And as the water falls, it goes down the roof and back into the house because, well, it isn't really, the landscape isn't um, really pitched properly and you don't have gutters on it. So we want to make sure that when we see this stuff, we're calling it out. It's just something that has to happen. And when you're doing home inspections and you're looking at the oven or you're looking at the um, any type of prevention of water, so like your dishwasher, that's a big deal when you're looking at underneath around the gaskets and stuff like that. Look for staining because that's what can water can penetrate through there. So it can penetrate into like the cabinets around it. And I went to one house where it's a brand new house too. It's really sad. They put the dishwasher in and they never connected it properly, and so it was leaking. They didn't see it. Like I said, 11-month warranty covered it, but the whole entire cabinets were just molded. It was I could put my finger right through it. It was just so bad, and I felt so bad for the people because now they have to deal with all the things because it wasn't put in properly. So an ounce of prevention can prevent gallons of potential leaks later on. And regular maintenance programs is the easiest way to protect a home and its contents. So I always recommend like a home warranty or something on a house when I'm talking to my customers, just because it's one of those things that adds value. It does cost money, but it can help your customers. And when you're looking like underneath the sink, you want to make sure like your storage isn't too much. And like I will fill up every sink and then drain them and check with my hand and the flashlight to make sure that there's no leakage whatsoever. The reason why I do that is because I want to put as much pressure as I possibly can on those pipes. I want to make sure that I am doing the best possible job I can. And if it feels damp or something, I know, hey, there's some sort of leak there, and I want to look for that moisture intrusion. Um, and if you see any large hole or something, you definitely want to call that out too. It, if the floor beneath the plumbing penetrations are soft or stained, make sure that you are reporting that. It could have been a problem. It still could be a problem. The kitchen sink is a high traffic zone area, and many of that area can be affected with water if it's not properly installed, especially underneath. And then, like I said about the dishwasher, just check, make sure that it it's working the way it's supposed to work. Some of you guys are running the items, some of you don't. It's totally up to you. If you look if you can look behind the fridge, that's also another sign where you can look for moisture problems. A lot of times, like you can't get back there, so just kind of shine your flashlight on the floor and just see if there's any type of moisture, the staining or anything underneath the fridge. So a lot of times, like my in-laws left for vacation and they're left the water on, or sorry, they didn't leave the water, they shut the water off, thank God. And but the valve for the refrigerator broke while they were gone, and it damaged the a little bit of the flooring. Luckily, it didn't ruin everything, but they ended up with an insurance claim there. So you just kind of check around and just make sure that if you see moisture, you just want to just flag on it and just make sure that you're telling the customer. Beneath the range or the cooking stove, you look for underneath there. And I always look at the cabinets, especially on the sides, because it always swells like right on the side there. And so, um, yeah, oh yeah, and check the exhaust filter too. That's always a good one too, above the stove, because that always needs to be uh, looked at. So, if we need to look at other things. We want to look at how the plumbing is hidden in the walls, if we can. And if you look at this picture here, and it's funny that one on the left there actually looks like one that I actually did a long time ago, except for it had a drum trap in there. And anyways, I was looking when you're looking at plumbing underneath the bathtubs and sinks and stuff, just quick, don't quick look at it. Take your time and really look for effervescence, look for the plumbing issues, look for, especially if it's not properly put together. So sometimes like you'll have cast iron and copper put together, and now you should have had something in between there to a dielectric to stop that flow of electrons and cause issues there. And don't ever touch that if you do see that, if there's effervescence and stuff around there, or I forgot what that's called. But if there is, don't touch that, because I touched it once and psst, water shot right in my face. So never again. I just shut off the water and I just told the customer, hey, there's a water leak. It's signs of water damage on the flooring around the bathrooms. I always take my moisture meter and just kind of go on the back side of a lot of tubs and stuff. And I'll take my thermal after I fill up the tub to the overfill. And I try, like I said, I try to put as much pressure as I possibly can on those pipes, and then go on the backside of that wall and actually take a thermal of it, and then maybe even put my moisture meter on there and just see if there's any stain or any type of moisture. So that's kind of how I do it. And then with the sinks and stuff, I make sure that it's attached properly, because a lot of times those pipes may break because people have went in there and shifted their cabinet and they never screwed it to the wall, and then the pipe broke and they didn't even realize it, and then you're underneath the sink and all of a sudden you got a big problem. And I always tell inspectors, always carry towels just in case. You never know. So signs of water damage on the floor, signs in the bathroom, around the exterior of the tub. A lot of times they won't close the curtain all the way, and then you got moisture issues there. And a lot of times you'll see mold and stuff growing up because they didn't shut the cor the curtain. And so that's why we want to see exhaust fans too, and exterminate as much moisture as you possibly can in the bathrooms. You should be running those at least 15-20 minutes after your shower and get rid of that moisture. And of course, that should be um, uh, all that moisture should be outside. You should expend it outside. Anyways, yeah, that's kind of fun stuff. And then you want when you're looking at the water heater and the heating, ventilation, the HVAC system, you want to look at where it's located. And so like my HVAC system's up in my attic. I do not like it in there, but it's what they did. Now it's not as common, but it still does happen. Um, but you want to look at around that area and then underneath there too, because like if you're looking at your HVAC unit and it's in the attic, and sometimes they overflow. Sometimes there are water heaters up there. You want to look directly underneath where those systems are, because there could be a possible leak. And sometimes, it's time consuming because you see it after the fact. Now you got to get down from your ladder, then go back over there. And then all of a sudden you see a stain and you're like, oh, I didn't even see that before. And that's part of being home inspectors. I guarantee you're going to miss stuff, but we want to try to minimize that as much as possible. When you're looking at the exterior of your house, looking at that kickoff flash. Kickoff flashing is so important, and a lot of people like underrate it so much. I've seen so many issues because of no kickout flashing, and you think roofers should know better when they put on a roof, but they don't. And you can look at like the damage that it occurs just because that kickout not being there. I can't tell you how many houses I've seen where they haven't had that kickout, and all of a sudden you got just there's no wall there. It's just it's just vinyl. So, and then yeah, I think that's it on there. So the other systems that we really didn't talk about is like your water softener. When I'm looking at water softeners, I kind of look at I can't say the age, but how it looks. If it looks older and stuff, you want to make sure that, you look around the base of it and make sure that it's not leaking, and you want to make sure like the tube is actually running outside or into a drain or something. So when it fires up, you know that it's not causing moisture. Because I've seen it where it was in the wall cavity and when the the tank, the salt tank was right there, and then the tube was supposed to go outside, but instead it just went into the wall. And so then I looked behind there, and sure enough, there's just a big stain, water intrusion. And it's up to the um, people buying the house or the people that are selling the house to take care of that. So I just put further evaluation. It appears to have some issues here. So make sure you're putting that. Now, if the furnace system or your heating system is gas or oil, proper ventilation should be addressed too, because that can cause moisture issues too. And I always, recommend further evaluation from an HVAC technician whenever you have any issues whatsoever. And some people are like, they might call you out on it, but I would rather have them uh, go that extra mile than have them have a problem. One of my friends had carbon monoxide poisoning with their water heater. And so, understanding the ventilation and stuff of systems not only can prevent moisture issues, but it can also cause health related issues that could have been prevented if they would have had, me as their inspector instead of somebody else. So, uh, I like to use my carbon monoxide tester, and I do recommend that you take a course on it to understand how to use it properly. Not too many home inspectors use them, but I like to use them just because of the fact of my friends. And luckily, they all made it, and they're still alive and kicking. So as far as I know, I haven't talked to them for a while. Um, anyways, when you're looking in the attic, for instance, look at each one of the trusses. A lot of times, like what I do is I count the trusses. I know it's kind of stupid, but I just count the trusses, and it's like, oh, 1, 2, 3. And as I'm doing it, I just look up, look down, look up, look down, look up. And then if I can get to the other side of the attic, I'll look the opposite way and look up, look down, look up, look down, and just see if there's any staining or any type of microbial growth or something like that. And then everything that passes through the roof, I want to make sure that I'm checking on that. Sometimes you'll see like there's a big stain and stuff, and sometimes um, you can really smell it, and sometimes you can see it. Sometimes you're going to miss it. That's all there is to it. But we want to make sure that if you can see it, you want to make sure that you um, call it out if you see something that's not quite right. If anything appears wet, just make sure that you are putting that in your report. It appears to be wet. It and I always use those words like appear and because it kind of limits your liability there. So I like to use the word appears. Uh, the attic vents, make sure that most houses all have attic vents. So make sure that you either have it in the soffit and in the peak of the roof so that proper air is vented right. Like I said, I just did a brand new house, and the so hot in that attic. I'm like, wow, they got the vents on the roof. Well, apparently they forgot to cut the sheathing underneath there, so it's just wasn't working. It was hot up there. It was pretty cool. Um, it's pretty hot, but it was cool. Yeah. Um, so anytime you see any type of staining stuff, just make sure you're taking pictures of it. Look up, look down. Check for birds nest. Big thing because if there's bird's nest, there must be some sort of air leakage somewhere, which could lead to other problems, not only just pests, but moisture intrusion. And yeah, we don't want to see that. So just make sure you're calling that kind of stuff out. You also want to check out the insulation. If it still looks soft and fluffy, and if you are walking through those attics, make sure that you move the insulation away, but make sure you put it back the way it was beforehand, because we want to make sure that the insulation is doing what it's supposed to do. It's trying to keep uh, the the weather outside, and the weather inside. And then the HVAC system, we kind of talked about that. Got a lot of notes here, so just kind of going through it. When checking your attic insulation, be sure that none of the soffit vents are covered or blocked. That's kind of a good thing. Make sure those I forgot what they're called all of a sudden. Your baffles are in place. Stains around attic vents are a sign of previous moisture, or it could be moisture right now. And these signs should be investigated properly. And something that I do is I'll turn on the exhaust fans when I go to a house, and then I'll grab the scientific method of a piece of toilet paper and just make sure it sticks. If it sticks up there, I turn it off, take the toilet paper, and then on the outside of the house, I'll actually go to the vents on the outside of the house and take a picture of it so it's blowing so they can tell that it's actually doing what it's supposed to do. We want to make sure that, you know, it's venting properly because if you're not controlling the moisture, that moisture will control you just like water. Um, Basements, you want to make sure that basements uh, have a wide array of plumbing, electrical, HVAC, all that stuff. And you want to make sure that it's properly put in place. And if you see any type of moisture, especially like the older, what do they call it, 80% efficient furnaces, a lot of them didn't have a drain on the plumbing or the HVAC pipe that came out. And so what happened was all that moisture would just sit on the bottom of the motor and it would cause it to rot. And then all of a sudden you'd have a pinhole leak, and then pretty soon you got water everywhere. So a lot of those systems they learn by mistake, and it all depend on how the plumbing or how they put the stack on there, the PVC pipe. And I think it was like 2.5 inch pipe that they put up and then went across the wall. So that's stuff that you can actually look for. All basements all have that's funny. Sorry, I got a phone call. Just doesn't realize I'm doing this. What the heck, people? So, anyways, water pipes can sweat, so you want to make sure that you're looking at um the water pipes, make sure that if there's any mold growth, things like that, any type of signs whatsoever. Underneath uh bump out walls and stuff, you want to look at that too. So you can see in these pictures how wood dis the wood rot happened because they don't have any drip edge on the side there, and then probably it just wraps up underneath and then it just wicks up. So yeah, I think that's it on that.